All right, greetings everybody. This is Tarmo Danielsson, and I'm doing right now a quick update on a pet project of mine that I've been doing over the past almost 8 years. So let's get started. So what I'm going to be talking about, of course, is TRV. Yes, it means Tarmo's Radar Viewer. Oh boy, I'm pronouncing my name in English pronunciation. And let's get started. First, let's take a look at some history. And for that, I'm going to actually go to a presentation I made for AMS 2016 Orphans hashtag back in 2016, of course. And this is how it all began. First steps were made in November 2010, where I was able to decode metadata from level 3 data. And not only that, I had an idea as early as 2008, but then I didn't have skills good enough. Now, I did know a thing or two about programming, but number one, I didn't know Python, and number two, I didn't really know how the the binary formats work. Now, ASCII, no problem, but at that time, binary information always seemed something very elusive. So this is situation November 2010, and during the same month, I already could render some crude images. I'm not quite sure if even the timestamp is on the left one is correct. Maybe it could be one day off. I remember having a bug about that in the very early days when I goofed up when converting the metadata in level 3 information into Unix timestamps. Now, initially there was slow progress. Both are pretty much the same. Only over here the screen cap is missing a menu bar and the title bar. But this was pretty much it. Basically, just simple decoding, nothing too special. Now, I started putting more effort into it in early 2013 when I extended it beyond a few level 3 products like reflectivity and radial velocity and stuff like that, because I was getting more into the field of radar meteorology. I had a course in the university on introduction into radar meteorology, and I kind of started adapting the program into my experiences in the radar field, and so it began. Now the development has been at the time was occurring, and even now is occurring in bursts. Like there could be a bit of development, then there could be a long hiatus. For example, I just came off a two-year hiatus at the beginning of the year. Part of it was, of course, exacerbated by the fact that I wanted to convert it into Python 3 and made some changes under the hood. But yeah, this was kind of the early years. And yes, as you can read from the bottom, it means Tarmo's Radar Viewer. The abbreviation works, by the way, in both languages, because in Estonian you would say Tarmo Radarivator. And by the way, Estonians, don't worry, I will be adding subtitles afterwards to this video. Now, I'm going to skip over it, mostly skip over it, because this was the situation in 2016. It has changed a bit. Now it is still as Tkinter GUI application. Drawing is done by Pillow. Now, data formats, there are a few more. First, level 3, yes, it's a homegrown decoder, but level 2 now is also a homegrown decoder. In fact, I've gone as far as adding support for legacy level 2 formats, so I could even visualize radar images from the days of Hurricane Andrew. HDF5, and nowadays there are two HDF5 supports of the same module, but pretty much it can read ODIM HDF5, which is kind of the lingua franca here in Europe, but also the HDF5 as it was defined by the Dutch Weather Service, and which they are releasing into the open data output. Not listed here, but was added this year, was also BUFR format, as it was done by, at least in the implementation by Germans. Basically, I was making a decoder so that I could decode open data radar images from the German Weather Service. They also have an open data output. And additionally, I've tinkered a bit and added also support for Iris Raw, and very crude support for DORADE, DORADE. Now, it is rather probably far more crude, because obviously even the moment names can differ by particular application. So yeah, but this one is still valid, the last paragraph. It's mostly toy for myself. Install is not really turnkey unless all libraries are present. Now, I've been recording some videos on virtual machines trying to illustrate the installation process in different platforms. So yeah, I'm going to get back to here. I'm now going to skip over because this one is still relevant. So basically, before I'm actually going to leave it afterwards, because first let's try to take a look how this thing is being installed. And I sincerely hope I didn't lose the screen share now at this junction. Now, first let's get started under a fresh Ubuntu installed on a virtual machine. Now, I prefer to use Git, and I recommend to use Git, but if you don't use Git for some reason, this is how you can still take the code from GitHub and download it as a zip file. Just get it and unpack it to a place from where I could find later. Now, this is only half of the task. Next, you need to install some dependencies if you haven't already done so. And now this is simulating a completely fresh machine. So Ginter, basic from package repository, you just need to get Ginter, pillow with image DK and H5 pipe. All the other required dependencies are coming with them. Now, why did I just log in and log out and log in here? The reason is that when you have freshly installed TK, I've noticed, at least on the virtual machine, it doesn't want to play well unless you restart your X session. Okay, now it started again, so let's close it. Now on Windows, now this is kind of the situation here on Windows. Yes, some people still use Windows. First, of course, the same thing, downloading the code, unpacking it from a place you could find it later. Now, over here, since I also use this, this is kind of my main virtual machine for Windows, so while I'm trying to simulate installing all the necessary things, some of these are already coming from caches. But basically, yes, once again, if you haven't installed Python, install Python, and afterwards also the dependencies. Since Windows install comes with TK by default, you just had install two packages if you use Python pip repository, H5 pipe and pillow. Once you install that, you are also going to get the rest of the necessary dependencies with them, because they also require them. And that's the situation. So let's carry on right now. And the time now is 3:12. A bit of a recursion here. Let's hope I don't lose the feed again. Okay, so let's try to get this thing started now. So let's run it. Now, if you run, there are two run scripts for Linux and also OS X, by the way. Run and run Python 2. Speaking of OS X, now be mindful of the caveats about TK and Mac, because the Python website says the TK is applied with Mac OS is a kind of buggy, so you probably need to install a third-party TK and also a newer Python, and stay clear from what comes from the factory. But on the Mac platform, once you've installed Python, you should be also having access to pip repository. Once again, the same thing, H5Py and Pillow, and during the installation of those, the rest of the dependencies should be also coming. So now let's run the thing. And this is how the window looks like. And now the user interface by default is in English, but it has also two other languages. And once again, Estonians, don't worry, eestlased ärge muretsege, ma panen pärast subtiitrid alla, I will add subtitles later to this talk. So I'm doing my part to keep this language alive as well. And yes, the third language is also I actually had to tinker a bit to get this working somewhat properly on Linux and also on the Pillow, because neither were wanted to play with characters, and huge caveats on the third language. لأن صحيح أنا أعرف لغة عربية لكن قليلا فقط. What I just said was, yes, I know a bit of Arabic, but a bit of, so there could be translation errors, but why it came there in the first place was actually a sign of solidarity with the weather enthusiasts in the Arabian Peninsula and Saudi Arabia, because their weather service, a bit of subtweeting here now, their weather service decided to fight social meteorologists by blocking public access to radar imagery. For example, they are expecting some active weather these days, but pretty much even I can probably just track from lightning detectors and satellite imagery, because no radar for you. But I digress. So let's get to the user interface. We've got plenty of buttons here. We've got some menus that are currently disabled. So let's open a data file now and take a look at it. So I'm loading by default in the example file. You can also see these weird tornado signs. These tornado signs are actually part of a feature which I've added here as an example. Basically, besides just drawing radar data, it is also possible to, let's say, plot things on the map. In this case, I've plotted SPC tornado reports from this particular day, 20th of May 2013. And the feature is called dynamic data points. So you can add data both online or offline. This is a JSON. These are in JSON for JavaScript object notation format, and I have a bit of a, and I have in fact a bit of I have a bit of a documentation in the doc directory. So yes, there are different types of data points. They can be shapes, they can be a single point, they could have text, and so on and so on. And when I was preparing a presentation for the MS 2016 Orphans hashtag, I actually did this plotting radar sites and hurricanes paths and so on. So now basically API is there to do such things. So here's an idea for the coders. And as shown in the presentation below, one can also override color tables. So for example, you can go grayscale if you want. Hurricanes look pretty interesting in grayscale, I must say. Now, so let's get started. For now, I'm going to turn off the dynamic data points. This is how you do it. As you can see, there is no check mark here anymore. Now, if we reload the image, these tornado signs are no longer appearing. So let's pull up now some level 3 data. This is one of the 3 live data, real-time data sources that I have that can be accessed through this application. So I understand there is a bit of activity in Florida. So let's see. I'm just shooting from the hip, so might not see anything. But this is I'm kind of trying to show the workflow here. Okay. That one is a bit too. Let's see, Fort Lauderdale. Fort Lauderdale, of course, is served by Miami, probably. So I'm trying to kind of come up. Tampa. Well, that one should be somewhere in the northeast. Once again, if you change the site, once again, you need to use the current data option to make this into effect. Here we go. And this is current level 3 data, 1318 UTC, so a minute and a half ago. So now I understand some people like smoothing, and especially for level 3 data, because obviously it's with degraded resolution compared to level 2. And just as an exercise, I have added some crude linear interpolation. However, as you might know, I'm not really a big fan of smoothing, so this is designed to be rather crude and comes with a performance penalty. Basically, it interpolates the data pins, and as a result, by each interpolation, the amount of pins to be drawn as much as quadruples, and that comes with a performance penalty. So if the folks of looking for pretty pictures want to get away so easily, no. You need to spend time to get pretty pictures. But yes, let's hit now reload. This will reload the data in its original form. So if you, for example, made some modifications, which I'm going to show a bit later, then you can go back to the original view. So there's still one thing I haven't, that has been so far grayed out. This radial velocity de-aliasing. Yes, I do have kind of a crude de-aliasing algorithm in it, but it works good enough. It is semi-manual. It works good enough to maybe fixing an area of interest, but not necessarily the whole image. So once again, let's go to Moore and the infamous EF5. By the way, this is how you zoom. There are two. This is, by the way, you can also see the program in action. First, these sequences are basically sequences of one of these 4 operations here in the menu. And let's take this sequence and let's see if it has any effect. There we go. So basically we have this mode, panning mode. We have zooming mode. You can zoom in with left by holding down the left mouse button. You can zoom out by holding down the right mouse button. And if you just want to reset zoom, there is this button. You can also query data. And so you can investigate single data pins. For this is the data gathering mode, or somehow, or how did I call it in the early years. So now, never mind. Now the K2Gate share is here, a very crude algorithm. It just compares with the adjacent, with a previous array. So it's rather approximate. And over here on velocity data, you can actually see not just the display here in light blue, but also this over here. This is what I call kind of Doppler scale. From here you can kind of evaluate data and see how the data has or has not been aliased, or which Nyquist interval is it in. So obviously in the original data we were observing aliasing, and here you can see it basically goes in from one side and comes out from the other. Now when we switch to the processed version, you can see how it stays in the right interval. And you can use this this data query function also for other products. Let's now take this is currently Doppler scan. Let's switch over to the non-Doppler scan, which uses a bit of different scanning parameters. So here are the dual pole products, and we can also now if we run now the same mode, we can see, investigate, for example, the rho HV, or correlation coefficient. Right, let's switch now to reflectivity for the next toy. Now the pseudo RHI. So that's the button here. Let's click on it and select an azimuth. Let's put it right here into the debris ball. We're actually putting it right somewhere over here. And now we have a display. Now obviously it's a kind of approximate, but yeah. So right now here we have on y-axis we have height from the radar beam level, height from the radar site. So this is a bit of a caveat. So if you're using the radar 2 kilometers high, you probably have to add as much kilometers to what you see up here. Over here we have range from the radar, and here we can zoom in with left mouse button and zoom out with the right one. So let's zoom in now over here, and let's take the correlation coefficient. I'm once again kind of shooting from the hip, but you can probably see the debris being lofted into higher altitudes. So yes. Now let's get to the next button over here. What does this button do? What does this button do? Obviously people would ask. Let's show. Now this is for that I'm pulling up a rather crude file I derived from the geotape images provided by the Finnish Meteorological Institute, Ilmatiedenlaitos, in their open data output. So this is actually combining two scans. One is a long-range single PRF scan, and it also contains radial velocities from a shorter range dual PRF scan. Now, because they have different PRFs, you can clearly notice which of these areas are real echoes and which of these have made a whole round trip before, basically have reached the radar when it's already sampling another ray, or round trip or the second trip echoes. So yep, these echoes are not really here. And this is where this button comes into play. It enables to select an area and push it away from the radar by the amount of maximum unambiguous range. So let's do that right now. I pressed this button, and now I probably, since I'm close to the radar, well, I'm also selecting right now a lot of empty air, but well, there isn't anything that shouldn't be pushed away anyway. So let's pick this area and send it away. Boom. And here we are. Now they are where they at least approximately should be. Now, obviously, you can recognize the event 12th of August 2017, the mother of all thunderstorm events that year, what I called on Twitter as PD Estonia. So you can see these distant thunderstorms so far high up. Probably maybe the propagation might help in some situations, but they were so far high up that radar, it left second trip echoes on the radar data. And knowing the PRF, you can fix for that. And here's also this is a semi-manual thing that I've done. Now, at first, maybe you make a mistake. Now you can revert to the original file by pressing the reload button, and it reloads the file. You can also export what you're viewing as an HDF5. Now, it isn't probably pure ODIM HDF5, but I'm trying to get close to it, and it is close enough that this thing's ODIM reader can open it. And I've gotten some files generated from some sources also to open with PyArt. But there are some providers, Americans, who, for example, don't have the same amount of pins and same amount of resolution for all of the sweeps. I'm of course referring to level 2 data here, and that is what makes some decoders unhappy. Right, so this is kind of a reset button. This one allows you to pick a sweep. This one allows you to pick a product. In this case, since here on this particular elevation I only had reflectivity. So let's carry on. Now let's get back to the live sources. So as I previously showed, there is Nextrat level 3 ability, but there are also 2 European sources, Deutscher Wetterdienst, their open data output, and also the Dutch Royal Meteorological Institute, so Dutch Weather Service, their radar services. So let's pull up now. These two are a bit different in the sense that you are going to choose a site and not just going to select a site in the dialog. You're just going to choose a site in the menu. Let's take Memmingen. Now obviously Germany is seeing quite a bit of action at this point, and here we are. Germans provide reflectivity and radial velocities into the into their open data service. So right now, once again, I'm going to use an opportunity to investigate this data a bit. Now, this is how the Doppler scale display looks like for dual PRF data. And let's now take a look. Let's hop over to, we can see, these data bins are, well, approximately one Nyquist interval off, but we can fix that. Ta-da! Now, obviously, sometimes this fixing can do more harm than good, but as I've cautioned, but sometimes you can still show something from an area of interest, or at least get a better idea than otherwise through all the speckles of dual PRF aliasing. And this is probably quite processed because it isn't very noisy, but still some alias pixels slip through the cracks. So high five for Germans. So actually, this is rather clean. Let's switch back to the original image. Now to refresh this one, you just pick this side again, and now you can't just, this doesn't mean that you are F5ing it, because all of this is being cached. Now, I wouldn't like to DDoS the Germans. So basically, if the images are very new, it's not going to ask from the server until a certain amount of time has passed. If it has a cached version, it will stay with the cached version. And if you should you need to clean your disk, clear up disk space, that's you can clear the cache, but please use this feature responsibly, because the main goal of it is not to bombard the German weather service every time you want, let's say, check a different elevation or different quantity, because these all are in different files. And because they are in different files, it looks like a whole volume here, but you can't do a pseudo RHI. However, you can download files for a particular volume and, let's say, export them as an HDF5. Let's do it right away. And from that, you can do pseudo RHIs. Looks almost similar. But now if we try to make a pseudo RHI, here we are. And the next source is, and the last source is Netherlands. Now, Netherlands distribute entire volumes in one file, so they can be rather large, since they contain all the variables. Now, here's a bit of a caveat. I've had to guess some of the variable names, so corrections are welcome. But for the most part, it seems to work fine, and this is pretty much quite as much as raw as it can get. So yeah, and high five to Dutch for this excellent resource. And by that, I think I am close to reaching the almost at the end. You can, on help menu, you can see, of course, about program. You can see which Python version you are using. I'm aiming at Python 3, although for now I have been able to keep it backwards compatible with Python 2 as well. Here's some keyboard shortcuts. Now, I don't really use keyboard shortcuts myself, so they're kind of legacy from the early days of the program, but I haven't found myself using them. So let's finish out with the file menu. You can also load up a file by entering its URL, and also you can export the image, not just as an HTML file, but you can also export it as a picture. So let's touch GIF. Now load it up. Reader. And here's the image we just exported. And one functionality it also has is batch export. Now this is also rather crude. This is pretty much I made this so that I could make time lapses, for example, from finished open data images. So I could pick a source directory containing the radar files, then output directory. This is where the rendered images are being saved. Then I could, let's say, open up a particular view, and leave it open, and then have it iterate through the entire directory and save the images of them as separate frames. So that's how, for example, I've been doing some of the time lapses on my YouTube channel. And with that, I think I am about done. So let's see. Yes, I touched this. Right. So the status right now, 2018, is that it's still mostly a personal toy. Some may find it useful. It still has quite a bit of rough edges. And sometimes I'm more active developing it, sometimes less active. For example, for now, I tend to perhaps find the active development down for a few months, as I have some other projects to attend to. And also I have an exam in May, for which I, of course, have to revise. But that's pretty much it. So with that, I am actually going to sign off. And thank you very much for watching. Have a nice afternoon, and until we meet again. Bye-bye.